Thank you very much for coming in. So I'm Yunus Aksoy. I'm a professor of economics at the Department of Economics, Maths and Stats at Birkbeck. And this is a talk, part of the BEI Engagement Week, Resilience in an Uncertain World. So actually I will be talking about something that's slightly less uncertain than many other things that we are facing. So that's really the so-called aging population. And I start to work on this together with my colleague here, Ron Smith, and some other colleagues. So about 10 years ago, at the time there was not much of a actually discussion going on in economics. And I started to work on these issues, and somehow we think it's taking more, I think, space in public debate. So clearly we are living in uncertain times, so there are all these things, the climate change, a major issue that's affecting our lives and will affect more likely in the coming decades. We had the 2008 global financial crisis, so major event. We had the Brexit for the UK, definitely affecting our lives, creating a lot of uncertainties as well in various ways, COVID, and now wars like in Ukraine, etc. So there are really interesting times in some form. But relatively speaking to all these things, basically there is the other type of issues that are happening actually at the background, essentially shaping our lives already a lot, and they will shape our lives much more in the coming decades. And that one of the things that I will focus on today will be the so-called aging populations. So we prepared a sort of a Birkbeck REF impact case study on this issue, and we think there were a lot of impact, especially around the certain policy institutions, and even on issues like migration, etc. in Germany. So there are profound implications of this aging population, both in terms of the quality of life that we are living in, and also there are issues related to equity, intergenerational, intragenerational. And we don't think basically there are a lot of focus on this, particularly equity issues as well. So what is aging population? Essentially it's a global phenomenon that started somewhere around late 1940s up to the 1960s, that's associated with sort of a substantial fertility increases. And then subsequent fertility rates started to decline after late 1960s, in conjunction with, throughout the period, increasing the longevity. So fertility rates started to decline late 1960s. Around the same time, longevity started to increase across the globe in substantial form. So this particular period between the late 1940s till late 1960s, and those who are born actually in that particular time period, is associated with the so-called baby boom generation. So, and that generation, so I'm probably just at the very end of this baby boom generation, so born in 1969. And this baby boom generation is starting to retire slowly, but that had quite an important effect on the way we are actually organizing societies. So I will show you a few things on that. So the way I want to organize the talk is I will start with sort of some data. I want to set the scene in some form, and I will refer, following that, the macroeconomic implications of this aging population in the medium to long term. I will try to explain the data with some theoretical arguments briefly, because it's a very complex phenomenon, but we have a sort of a simple proposal how to explain what we are observing in the data. That will be associated with so-called also productivity issues in general, which is also a kind of a commonly discussed issue in the UK as well as elsewhere. This has also implications for the equality in general, and particularly within the context of the pension reform. So the statutory retirement age, for instance, is kind of one of the big issues. In France, there's a big debate and uproar happening there as well. But even kind of even if one agrees that the statutory retirement age should be somehow changing, just uniform changes will affect populations in an extremely heterogeneous way. And so that's going to be one particular issue I want to raise. And finally, given this phenomena that we are experiencing, basically what are the possible resolutions? And there is no real answer to that. I mean, I will basically provide some ideas what are kind of possibly interesting to look at, but it will be an open-ended part. And hopefully we will have some time to have some Q&A at the end. So what is basically demographics and the population aging is essentially typically they are linked to sort of lower population growth and lower labor supply. So basically people studying economics tend to be worried if the population growth is basically is decreasing, which in turn will translate into some labor shortages in some form. But actually there is another element to that, a more general view, if you like, is the so-called demographic structure. So basically that's the proportion of the population in each age group at any given time. And they may have different implications for various macroeconomic indicators that we care. So for instance, different age groups at any given time may contribute differently to saving in general, which in turn will affect basically the investment activity in some form. Each age group may have different contributions to productivity gains, and they will be reflected typically in the wage profile of the population in the economy. So basically when you are young, typically you start with a certain level of human capital, but then you gain experience over time, and that will be reflected in your wages, but also your productivity will be simply contributing to the overall economic performance in some form. Different age groups may contribute to differently to innovation activities. So basically, typically, I will show you some data on that. Young, so let's say, I mean, to give you the very extreme example, the Nobel Prize winners. So typically, they get the prize when they are sort of later ages, but typically for an idea associated with when they were about sort of 30, 40, etc. So the innovation activities are also somehow probably linked to age structure in some form. Also, each individual age group create different investment opportunities. So given their size in the population, their share in the population, firms will start to basically produce certain goods to address their needs in some form. So that's kind of the idea. So just while we have this sort of the population growth that's important, but also the age structure of the population will affect the macroeconomic performance. So the global population is basically still increasing. So according to the UN Population Division, in 2020, the world population is about sort of 7.8 billion people. And they also have fairly accurate projections about the fertility and longevity. And they predict that by 2050, the world population will be about 9.7 billion people. And by 2100, it will be about 10.8, 10.9 billion people. So population will keep on growing. The issue is that the population is increasing typically not because the newborns that much, but mostly because people tend to live longer. That's basically the longevity is leading to an increase in the world population overall. But it's a global phenomena. So both fertility rates are declining as well as longevity is increasing. So I will try to sort of switch now to this particular link that worked. So that's basically coming from the OECD. So just kind of a sample of OECD countries. So here, I think G7 countries. So basically, this shows you have the years on in the bottom on the horizontal axis. So let's say in 1960, somebody who was born in 1960 would be expecting to live in the United States about 66 years or so. And somebody now born in 2020 would be expected to live up to the 76 year of age on average. And you can see the sort of the steady increase over time. And we can pick up other countries here. So basically, this is Italy. So starting from 67 years in 1960. And then, as you can see, sort of a fairly steady increase up to 80 years old on average for those who were born in 2020. So there's a, as you can see, subtle decline here and probably associated with the impact of COVID. So the other, if I can come back, data I want to show is the so-called fertility rate. So again, this is the OECD, same set of countries. So we are looking at the United States again. So in 1960, per woman, there were about sort of 3.62 children in that particular time year. And you can see basically kind of a fairly steady decline afterwards, and it keeps on decreasing. So basically by 2020, it's about 1.71. US is one of the better countries in that sense. So basically you have, for instance, here the other extreme again, Italy. They had about sort of 2.4 in 1960, so 2.4 children per woman in 1960, and now it's about 1.27. So basically, so typical replacement ratio is considered to be sort of 2.1, so to sustain a certain population age structure. So these are sort of the two major trends, if you like, I wanted to show. Now, I want to also show you a few countries, basically, and kind of focusing on this individual evolution of this age structure, given this UN population division's estimates related to the past, as well as the predictions about how the population will evolve over time. So these are the shares of individual age groups, but now in blocks. So basically, the blue line here is showing the share of the 0 to 19-year-old, starting from 1950, and then red is the 20 to 39 years old, their share in the population, and then the green one is 40 to 65, and 65 plus is given by the violet figure. So sometime in 1950, Japan had about sort of 45% of the population, essentially either children or students or very young. So that's fairly significant. And at the time, basically, they had about 5% of the population who were about 65 plus. So you can see sort of, and the other groups are in between. And so as the share of the older population is increasing, the share of the very young are decreasing. So, and typically, you will see this in this sort of a pyramid form. So basically, you will have at the bottom the youngest, and in the middle, sort of the working age population, and on top maybe the retirees. So basically, but then if you would do it for each individual age group, you will get sort of roughly a pyramid form that's basically reflective of this earlier 1950s, etc. But nowadays, basically, Japanese case is kind of extreme. So they have this sort of the inversion of the pyramidal structure. So basically, you have quite a few in the bottom, so very few young, and quite a few older population in the top. So basically, there's this inversion. But it's not a Japanese case only. Japan is interesting because many of the things that we observe in Europe, in the US, in other countries are actually preceded by the events in Japan. That's why I picked up Japan. And their economic malaise, if you like, also started actually earlier than many other countries. So that's the world data. So you have this goes up to the sort of 2100. So again, given the predictions and given the trends in the longevity and the fertility, you get basically a very similar picture. So globally, sort of in 1950, about 5%, 65 plus, 45%, 0 to 19. And then you get again the same picture basically simply showing up. So again, the inversion of the pyramid. UK, probably of interest to us. So it is also showing a similar picture, much less strong, basically, compared to Japan. But still, we have this particular phenomenon as well. So the younger share basically is decreasing, and there's a quite a strong increase in the older population. So median age, and again based on the UN predictions, so basically in 1950 across different countries, so basically, and there are now countries that are as we consider sort of advanced economies compared to sort of emerging markets, so like Brazil, Turkey, or Nigeria. So the median age is also increasing over time. So basically, not surprising, you know, the people live longer on average. So just basically, but then there's also a kind of a convergence. So it's a global event. That's what I just want to mention, because typically we tend to associate basically, oh, aging population is just only happening in one part of the world, but it's really happening everywhere. So what we do in this research, we started this research, so essentially we look at the impact of this aging population on key macroeconomic variables in an empirical sense. So basically we have a econometric environment, and then we also have a theoretical argument, basically whether we can explain some of the things that we observe in the data with some theoretical ideas. So it's a kind of a complex problem, because demographic changes, so the age structure changes are happening in a very slow fashion. So it's not very easy to measure the impact. But at the same time, they are quite predictable. So basically, fertility rates are persistent. And when a number is known in a certain year, let's say 2.1 children per woman in 1950, you know that the labor supply effects will be materializing, let's say, in about 20 years' time. So basically, the children in 20 years' time will be active in the working population. So that's kind of a, and along with it also, because the medical advances, of course, it helps, the lifestyle changes help. So we tend to have this sort of the extension of life in general, and they are also fairly steady. So there is a lot of basically predictability in the demographic trends compared to things like global financial crisis or Brexit or COVID, etc. So what is the good thing about this is that one can study the sort of the causal impact of the demographic structure on key macroeconomic variables, because you know something has changed, let's say 20 years ago, and then you can see the impact of this basically in the 2 decades. So what we do is basically we look at the sort of the first the so-called short-term impact, and then compute the dynamic propagation mechanisms of this dynamic of this demographic changes on key macroeconomic variables later on. So, and we look at several variables like output growth, investment, savings, hours worked, real interest rates, and inflation. So basically, for a sample of 21 OECD economies from 1970 to 2014, and given our sort of estimates, we try to predict what the future can look like. And that's basically what I'm going to do, basically. So I will show you sort of 3 parameters and their impact on the variables that I will mention again in the long term. So 3 parameters representing essentially beta, as represented by beta 1, beta 2, and beta 3. So beta 1 is the share of the parameter associated with the share of the young in the population between 0 to 19. Beta 2 is the share of the population from 20 to 59, and beta 3 is the share of the population parameter associated with the share of the population from 65 onwards, so 60 onwards. So and there are certain numbers here, so you can see sort of G is the impact of this young age group, beta 1s, represented by the beta 1s parameter, on growth of the OECD economies, so from 1970 to 2014. Long-term impact. So basically, young tend to contribute positively to growth. So 0.0 to 19 years old contribute positively, not very significant, to the growth of the economy. The working age population also contributes positively to the growth of the economy. If the share of the older population is increasing in the economy, they tend to contribute negatively. So that basically that's kind of the broad picture that you can see. Investment, likewise, basically, if there are young, so if the share of the young is essentially increasing in the population, then their contribution to investment is positively associated and it's significant. The working age population also is positively contributing, but it's not significant. And again, if the share of the older in the population is increasing too much, then investment is negatively affected. So savings, likewise, the similar picture comes out. So you can follow basically the science here from the beta 3 and the working age population here and the young here. So typically, you get this picture. One of the interesting parts is that the real interest rates, so basically one of the things that characterize our recent lives, basically since a couple of decades, is the steady decline in the real returns overall. So the why we are getting sort of the zero bound of interest rates, etc., may be related also somehow to the aging population. So I will comment on this again. So, but the real interest rates tend to be associated, if the share of the young in the population is increasing, then the real interest rates tend to be negatively affecting so the share of the young tend to affect the real interest rates negatively, and likewise also the old tend to affect the real interest rates negatively, whereas the working age population tends to push the real interest rates up. If their share is increasing in the population, that tends to push up the interest rate. Sorry? Is there a reason for that? I will try to provide an explanation to that. Yes, I will. That's where the second part or the theoretical part. That inflation is actually a lot of people are quite interested in inflation as well. So the inflation tends to be increasing in the share of the young and the old, and tends to decrease in the share of the working age population. So that's also an interesting statistic to bear, and that's much more difficult to explain, but I will try to comment on this a bit. So now, these are sort of the estimates that I showed, and what is sort of the prediction, given these estimates, basically about the key macroeconomic variables over time. So these are basically countries, US, Japan, Italy, and France. So as I said, we've studied 21 countries, but so you can see basically starting from a sort of a initial growth rate of US economy in 2010, given this sort of estimates, how the output growth in the medium term will look like over time. So basically by 2030, you will see that the growth rate in the US will decline quite drastically from about 1 percentage point, long-term growth process. So from 3% to, roughly speaking, 2%. And likewise in Japan, Italy, France. So basically, and they are significant. Interest rates, as you can see, sort of also in a downward trend. So basically, given our predictions, the real interest rates are expected to go down for various countries, or for all the countries that we are looking at. Investment is also going down across the board, long-term investment, and savings also go down. So basically, almost every key variable that you can think of is expected to sort of to contract, to go down over a let's say 20 years period. These are conditional predictions. So you can sort of compute, if you like, the for each individual country the long-term or medium-term growth on average, let's say projected at 2025 against the projection in 2015. So on average, the long-term growth rates of all the countries that are in the OECD sample are expected to go down quite drastically. So basically about sort of, 0.5 to almost 1%. So these are kind of fairly significant numbers, because these are the numbers that basically generate employment, the activity in various forms as well. And they are all significant too. The difference between the projected growth rate in 2015 against 2025 is significantly declining given our conditional predictions. So now there's one puzzle that I need to explain. So basically, let's say I have a little story here, but I will try to kind of put this in a bit more generic form. So if the long-term interest rates actually are estimated to go down, so the implication should be that the investment should pick up, because now it becomes cheaper to finance an investment activity. But our conditional predictions show that the investment is also declining. So the cost of financing declines are not necessarily translating into sort of a long-term investment pickup. And here, the idea will be just to whether there is a role for the productivity in general. So whether productivity is affected. Why? So let me kind of give you this particular statistic here for the UK productivity. So as you can see, the UK productivity output per hour for the UK was fairly sort of steadily increasing up to, let's say, the global financial crisis, and afterwards there's a fairly strong decline, or it starts to stagnate basically quite drastically. There are several explanations to that, why this can happen. So it can be related to urban structures, it can be related to the funding conditions, it can be related to the central bank policies, related to this quantitative easing policies that basically happened. So also we think that basic demographics may be playing a role. And let me kind of try to motivate this. So basically whether productivity gains have been basically affected by the changes in the aging population. So here is the sort of a very simple plot here that shows the you have the age group on the horizontal axis and the frequency of the ideas getting a sort of, let's say, Nobel Prize worthy ideas associated with a certain age. So basically if a certain Nobel Prize has been won, when this idea was basically conceived by this Nobel Prize winner. So typically, so they are peaking around sort of late 30s. And then just basically you have this sort of a bit skewed distribution. And this is true also for great inventors. So basically great inventions that happened. So typically, young tend to basically push maybe more bold with a lot of experimentation, etc. Ideas that are basically becoming and changing the way we are living in quite substantially. Please keep that in mind at the background. Also, actually, I can show you the other figure that I can, I put it at the appendix, but I can just show it at the very end. So this is the US granted patents associated again with the age distribution. So they typically peak around the age of 40. And this is quite stable. I mean, there are some changes, but the granted patents are also typically peaking around the age of 40. So just to complement the great inventions or the Nobel Prize winning ideas type of thing. So what we do to account whether this is really important, in the same specification we had before, we add basically so-called patent applications per capita in a population. So basically whether the demographic age structure changes affect the per capita patent applications in this 21 OECD sample. And we find actually fairly strong impact. So the very young, if there are too many children in the economy, so they seem to have a negative impact on the patent applications. And the working age population, so let's here characterized by this middle group because of the data constraints, so it's positively affecting. And again, you have a mild but negative impact of the older age groups basically in the patent application. So the ideas production may be affected by that. So now we have a theoretical argument just kind of to show, to respond maybe to some extent the gentleman here. So we have a fairly complex model that has a lot of heterogeneity in demographic structure. There are young dependents, we introduce human capital accumulation, and we have endogenous productivity. But this is the kind of the model that I kind of described here, but very briefly I will be just mentioning one or two things. So basically we have different generations, so the young, workers, retirees, but also there's actually feeding of the sort of ideas production into the model that's linked to the sort of the age structure in the population. Why is it important? Because the ideas are only rarely becomes products. So basically lots of ideas are being produced, but then just only very few of them basically become sort of a certain product or a kind of a prototype. And these prototypes only rarely becomes a sort of a successful product, etc. So basically you need to have a lot of ideas, lots of experimentation with prototypes, etc. So it takes time. Why it's important? Because we are interested in understanding the long-term impact of the aging population. So basically there should be some protractive process basically that leads to this ideas being simply generating some goods varieties that are available in the economy. So let me kind of, that's the background, and I'm more than happy to sort of go in detail if there are further questions on that. But so what we do is basically two simulations. So one is basically the so-called aging population simulations. So we are essentially observing a sort of an increase in the fertility of the, let's say, 1950 age group, born in 1950. So you have a sort of a jump in this. So now we can talk about the dashed line. And So that translates in the share of the working age population initially to increase. So basically there is more labor supply because more babies are born in the 1950s. So sometime a couple of decades after, the fertility simply drops. So basically you start to see a decrease in the working age population, share of the working age population. So the initial impact is the share of the retirees in the population initially declines but then picks up again. So if there are, this fertility increase associated with the baby boom generation is basically is associated with ideas production. So that basically ideas simply are becoming more pronounced, and you will be getting more adopted products in the economy. So you see a sort of a peak in the growth in the economy. Adopted products, but also in the peak in the economy. Interest rate implication of that would be, so as the ideas are simply coming in, there are a lot of ideas coming in, the corresponding returns associated with the capital investment is also increasing. So that basically picks up, that's shown in the picking of the real interest rates. So typically, sort of sometime mid-1970s, 1980s, you get basically the interest rates really, steadily increasing. And then as the share of the working age population starts to decline because of the fertility declines following the baby boom generation, you start to see a sort of a secular decline in the real interest rates over time. Because fewer people are basically innovating, therefore fewer ideas are simply translating into some investment activity. So the investment initially is decreasing. Why? Because there are too many, the baby boom generation, too many children are there initially, so you have to finance their education activities, so basically more resources allocated for the education. But then they accumulate human capital, so they start to produce a lot of ideas, more ideas being translated into investment, and then you see a major increase in the investment activity. So as their share, as the working age population is starting to decline, following the fertility, starting off the following of the fertility declines, you start to see a decline in the investment activities. And etc. So basically, more or less kind of it follows. So our argument is that the baby boom generation led to a sort of a lot of ideas production in the 1970s and 1980s because that impacted the share of the working age population very significantly. That led to an increase in the real interest rates, return on capital in the 1970s, but then followed by a sort of a decline in the real interest rates. And that's the so-called, if you like, the secular stagnation type of arguments that you may hear in the news, etc. This is a simulation that I just wanted to mention about the aging. So here what I say is that, so we keep the population growth constant. We say that while the fertility is decreasing together with a longevity increase. So basically you get the same population growth rate, but fertility is decreasing and longevity is increasing. So you get the straight line here, so ignore the dashed line here. So the impact of this one will be, first, the share of the young workers will be decreasing. So basically they are starting to decrease quite drastically. And because the people are expecting to live longer, so the share of the retirees start to increase basically quite drastically. So that means those who are engaged in some sort of ideas production in some proportion starts to decline in the population. So the impact will be initially now those in the very young age group there are very few of them. So they get a lot of capital investments, a lot of human capital investment, a lot of education spending is basically going to be allocated to few kids out there. So they are quite creative. So they just really create ideas because they get a lot of this education spending. So initially it's kind of quite good. But then because their share is so little in the population, so this ideas production starts to contract. So, and this is kind of following also this followed by also the growth in the economy. So you get basically a subtle increase in the output initially, output growth, but then there is a major contraction in the output in the following episodes. Investment likewise, so basically you get a sort of a bit of an increase because of this initial human capital investment to the few, but then because there are very few kids out there ultimately that become workers and therefore ideas production is affected, you get basically fewer investment opportunities also being materialized. So basically the idea is simply that one cannot just simply explain this sort of the big decline in the real interest rates by just simply with the idea that the people are expecting to live longer, they will therefore save a lot for their retirement, therefore they will increase their demand for the assets out there, including housing. All the house prices or any asset prices will go up, but then the returns will be associated with this asset investment will be declining. So that's not sufficient to explain why, because the interest rates are declining, must be translated into some investment pickup. And that doesn't materialize, so there must be some supply side stories at present. So there must be something related to the productivity, return on capital, that does really not translate into investment activity despite very favorable financing conditions out there. That's the demographic story. I mean, it's just one thing that kind of is typically not so much basically discussed out there. So now this is basically the background. So this, if you like, this is the environment that I wanted to mention, and our predictions, empirical predictions, and our theoretical arguments. So there are a few things that I also mentioned related to inequalities in general. So this is the sort of the, I mean, I don't know the names very well, but there's a silent generation, 1928 1945 generation. Baby boomer generation is typically 1946 to 64. Generation X, 65 to 80. Millennials, 81 to 96. And the Generation Z is associated with those born in between 1997 to 2012. So I just posted the US sort of wealth associated with these generations. Of course, the younger is expected to have very little wealth. I mean, so they are just very young, and they hardly have anything out there. Millennial is also not too far, actually, sort of just even though now they are almost their 40s. So basically, the average mean wealth is in the order of 27,000 US dollars. Generation X sort of is better, of course. Baby boomer generation has a much more wealth on average and the silent generation. So basically the starting conditions of these generations are going to be quite different, not only because they are young versus old, but also they, I think, face basically different type of wealth accumulation conditions. So just to at the background to remember that. Why is it important? Because ultimately, so if you own a house, so at certain, like every household is dreaming in some form, and the value of the house is increasing. So just basically for a Generation Z to enter the housing market will be rather different compared to the ones basically that basically faced these opportunities in the in 1970s, 1980s. So the initial wealth conditions are basically affecting the way they can basically accumulate wealth over their lifetime. So that's just basically initially, if you like, asymmetry that's present in some form. There is an issue also related to this, the life expectancy are very much conditioned on what type of background you are coming from. So basically, and also the quality of health when we are older, getting older. So the typically what you find, especially coming from the Norwegian data, that's kind of shown, but it's kind of becoming more and more basic evidence is being accumulated. So those who have a better education in general tend to have a sort of a higher life expectancy when they get older, but also they have a better quality of life compared to their less educated counterparts. So, and that's kind of important because this heterogeneity, given the education levels and their life expectancy and the quality of life later on, is going to be quite important when you decide about the so-called statutory retirement age. I mean, if you want to change this particular number, 65 to 67 to 70, etc., a uniform decision will affect basically different groups in a very different way. Here I want to show basically a couple of sort of this type of data here. So this is the age groups here are given on the horizontal axis. So the compulsory education, so the mortality rate is basically very low, of course, when you are very young, so 27. And it gets basically higher as the person is aging. So just the compulsory education is associated with sort of in general, higher expected mortality rate compared to a college graduate. And that's basically, kind of high school or compulsory are quite similar, but the college graduates are basically expected to have a higher mortality rate when they are getting older in general. Life expectancy in years also affected different groups in a different way. So basically, those who have a higher education, like college graduates, are expected to live basically on average longer compared to those who have a high school against the compulsory education. So basically, so why is it important? Because if you increase the statutory retirement age for everyone, so essentially those who on average have a lower level of education will be essentially contributing to those who had a higher level of education by their retirement, because they will probably not even around. And that's kind of an issue. Also, the quality of health as the people are getting older is also quite different. So basically, so just the bad health reported by those who had a compulsory education against the college graduates, according to their age groups, is much higher compared to the college ones. So basically, even if the people live longer with a compulsory education, they are expected to have a sort of a much more difficult life following their retirement. But that's also kind of related to class in general, class issues. So basically, because the kind of education level is related to the level of also what type of job people do, what type of occupation people tend to have. So typically, the blue-collar workers are aging faster in general than their white-collar counterparts. So basically, and that's basically also they are having a lot of so-called health deficit when they get to the retirement age. So basically, there's quite a bit of heterogeneity kind of connected to education level as well. That will basically affect their retirement contributions while they are working, but also they won't be on average living longer than their white-collar counterparts, but also they will have actually lower quality of life when they retire. So important is that ultimately when one talks about the pension decisions, pension statutory retirement age, it's important to consider this type of heterogeneities in the population. So what are sort of the possible resolutions, about this aging population problem in general? So one is possibly the obvious one is the so-called migration. So it's a natural course of events. So basically, and the world history is really is about migrations. In principle, it's straightforward to implement. So basically, skilled or unskilled labor can move from one country to another. But of course, there are major political challenges in implementing this, about security concerns in general. And also more maybe sort of a pressing issue is that this aging population problem is a global phenomenon. It's not just happening in one country or other. So basically, every country is experiencing this aging population. But if you look at the data, actually there is already quite a bit of evidence of the relationship between the decline in the fertility rates 20 years ago and the corresponding basic inflow of the migration in a certain country. So basically it's a scatter plot. So if the total fertility rate is low, the corresponding inflow of the migrants are high. In general. So basically, and this very, very simple econometrics, essentially only conditioned on sort of the country-specific effects. So you get sort of a fairly straightforward downwards relationship. So lower fertility is associated with migration increase. So this is happening. This is at the background. This is always happening and will happen probably in due course. But it won't be a solution in any form. Alternative. So because the aging population is kind of characterized by the labor shortages in general, but also the ideas production, as I said. So one can also think that, well, maybe robots will do the jobs for us. And that can be, just essentially we see that in everyday life. In supermarket tills or the really sophisticated robots in factories, etc. But is this going to be sort of going to be a resolution? So here is Acemoglu and Restrepo's basically picture. You have on the horizontal axis the change in the ratio of the old to young workers from 1990 to 2015 for a range of countries here. And on the vertical axis is the change of robots per million hours worked from 1993 to 2015. So indeed, those countries like Korea, which experienced a sort of a much larger increase of the older workers against the younger workers, started to basically get much more robots basically in the production process. So basically, I mean, it's a bit sort of not as clear-cut as the migration case, but there is definitely also these firms are simply responding to that in their production processes. So you get this sort of the positive association between the share of the older workers against the young, against the robots basically doing the job. But this is a very complex problem. So the, I mean, aging provides a sort of a justification for automation. So basically, and that's definitely, probably there are some productivity gains here. But at the same time, there's a distinction between the innovation and automation. So basically, robots cannot innovate. So basically, you need to have sort of ideas coming from the individuals in some form. So the creation of new products, new employment opportunities will be associated with sort of the people, unless AI starts to kind of create all sorts of ideas out there, which is very, very uncertain. And more pressing issue is also the fact that it may be very favorable, very attractive for the firms just to go for a full robotization, kind of, replacing essentially labor with robots. And this kind of what Basso and Jimeno call the robocalypse. So basically, essentially people are becoming jobless. At the same time, there should be some sort of a policy regime that's going to be taxing this sort of the capital associated with the robots in a very effective way so that it can be redistributed to the population in a meaningful way. So that's an issue related to also this policy in general. So the final points I want to make is really about the government and policy. So the what can be done? I mean, definitely the human capital is very important. So the investing in younger generation is crucial. And that's really because the productivity gains are associated with the human capital formation. COVID didn't help, of course, but the way the young in the population are basically funded for childcare, young parents as well, childcare, education, health policies, is really crucial for the productivity gains that may happen. But also at the same time, it may also relieve, to some extent, if you like, the pressures associated with being having kids together with having a work. So just kind of the regulations that basically put the child rearing to man and woman exactly in the same way. So just by Sweden is managing to achieve this. So just the paternity leave, maternity leave, exactly in the same way. Spain is managing that. I think that's really important sort of how to organize a sort of a human capital accumulation for the younger generation that will basically address this productivity gains in some form. The second, very important, is the older generation human capital formation. So the, I mean, for not only the intellectual, but also the physical well-being for the older generations. And Birkbeck is really the prime example for it, I think. Just also, this is really where we really see so much productivity gains by allowing this lifelong learning in a very rigorous fashion. The big issue as well, which I was mentioned, alluded in the previous slide, is that so any public policy that's kind of considering about the pension reforms, basically, it's not going to be sustainable to fund the pensions in the future and change basically in some form, must really consider this sort of the intergenerational and the intergenerational equity issues. So basically, I mentioned already about this intragenerational problem related to sort of the level of education and the occupations and the way the health and the life expectancy is evolving. But also there are intergenerational equity issues. So basically, those who will be retiring in, let's say, 30 years' time, 40 years' time, should not, I think, be sort of negatively affected by decisions today and that were not applying to the current retirees. So, that's kind of a issue that the policymakers must really think and at least start thinking about how to address this. How to fund, sort of, this is a big, big problem, kind of just this human capital investments in some form. And here I will go a bit sort of aside, but I will just say that, well, actually, one of the things that really happened in the last 4 decades in all advanced economies is sort of a spectacular rise in the profit share in the gross value added. So just let me give you sort of some little picture here. The capital share in the gross value added itself was actually declining from 2010 to 2020. Labor share in the gross value added, so the employee compensation, was also declining over time a lot. And what was really increasing spectacularly is the profits. And I think any policy discussion should really consider carefully what to do with these profits. So where do they end up? Do they end up with the people in some form, or just in the... and I think a policy about taxation is important. How to basically address this, not only about the robots that I just mentioned, basically how to basically capitalize on this sort of the replacing the labor forces basically in the form of automation, but also how to think about this profit share. And this is really quite a remarkable picture. I think this is becoming more and more important for us to think about. I think I will stop here roughly. Yeah, so we believe that the demographic structure is important and it's kind of something predictable. It's happening and it will happen in a much more significant way in the coming decades. It will shape our lives in some form, in every aspect. And unfortunately, many things are left out. For instance, I mean, just the cost of healthcare, etc. You know, but I didn't comment on that at all. But there is no free lunch. It's a complex problem. But I think there are good ways of dealing with this, especially if governments realize the importance of the human capital formation and investing and funding for this issue in general.